This video will deal with how to identify outliers in a data set. Very often when we have outliers, we want to try and identify those so we can eliminate them to prevent any skewing of the data in one direction or another. But we also want to make sure we use an appropriate technique that allows us to preserve scores that may be at the outer edges of a distribution but are still technically not outliers. And I'll talk a little bit about some alternate ways we can identify outliers and talk about what appears to be the most appropriate way to deal with them. Now, there's a couple assumptions we have when we do this technique, this outlier labeling technique, and that is that we have a normal distribution, so we'll have to screen our data to be normal using a skewness score or some other technique. We're also assuming the data does not have extremely large sample sizes, so if we've got over several thousand subjects in a sample, this won't necessarily work as appropriately. But if we've got sample sizes typically less than around 1,000 or so, this technique will work fairly well. So I've got some data here that I've actually kind of set up to be normal. So I know that this data is normal, and we're just going to go through the technique so I can show you how we would set up the criteria for determining which data may or may not be outliers. So our first step in doing this is to go to the Analyze menu. We first need to identify kind of the boundaries for what we consider to be using the boundaries we would use to determine if a data point is or is not an outlier. So we need to go to the Descriptive, Analyze Descriptive, and then go to the Explore option. And so we're going to use data set number 1, so we want to make sure that that data is entered in the dependent list box. We want to go to the Statistics option, and we want to choose Outliers and Percentiles because we're going to use percentiles to help us determine our boundaries, and then we'll then use the Outliers function to determine if there actually are any outliers. We also want to go to the Plots option, and we just want to see a histogram of this data so we can get kind of a picture idea of what this distribution looks like. Okay, click Continue, and then we click OK. So the first thing we're going to need in order to determine if we do have any outliers is we're going to need 2 percentile ranks of the data. We're going to need the 25th percentile and we're going to need the 75th percentile. We're going to use these 2 percentile ranks to then determine what the boundaries will be for determining if we have an outlier. And so we're going to use those percentile ranks and we're going to plug them into a formula. And so this formula we use uses a multiplier, and this formula was first promoted by Tukey as a way to identify outliers. And so we have a formula for the upper boundary for outliers, and we have a formula for the lower boundary of the outliers. So basically how this formula works is we take the third quartile and we take the first quartile and we plug those values into this formula. And then we use a multiplier of 2.2 in order to then set the boundaries for our outliers. Now, some authors will suggest using a 1.5 as a multiplier, and that was Tukey's original suggestion, was to use 1.5. Other authors have suggested using 2.0, but the problem with that is when you use either of those two values, you're actually kind of chopping off a portion of the normal distribution. And so some more recent authors have suggested using the 2.2 multiplier, so that way we're not cutting off the tails of a normal distribution and we're still including those subjects in our sample, but we're still able to identify what would be a true outlier. And so we would then take the values that we got from our previous output. So the 75th percentile, we'll go back really quickly so you can see that. The 75th percentile raw score was 363.8673, and the 25th percentile raw score was 334.9965. So we're basically going to take those values and plug them into our formula. Okay, so once we do the arithmetic here, we're going to come up with an upper boundary of roughly 427. So we take basically taking the third quartile score, performing this product, and then adding it to that third quartile score, and that gives us our upper boundary for outliers. We do something very similar for the lower boundary. We again are using the same formula, except now we're starting with the first quartile raw score. So here's that raw score. We plug the second half in the formula is the same as it was for the upper boundary. Once we have that value, we subtract it from the lower bound 25th percentile, and that gives us our lower boundary. So what we're saying in essence is that we have any scores that are lower than 271, we will consider them to be outliers. If we have any scores that are greater than 427, we will consider those scores to be outliers. So now we will go back to our output and look here in this table, which identifies the 5 highest scores and the 5 lowest scores. And we can use then these values here to determine if any of these values are the outliers. So again, our upper value is 427 and our lower is 271. So as we look at the output here, we can see we don't have any values that are above 427 and we don't have any values below 271, which is exactly what I expected to happen because this data was set up to be normal, so there should be no other outliers. Now, if we were to plug in the 1.5 or the 2.0 multiplier into those formulas we just looked at, we would probably end up with some outliers. And in that case, we would actually be kind of misrepresenting our sample because we'd be cutting a portion of the sample out that is truly not an outlier. So to summarize, in order to identify outliers, we can use the outlier labeling rule, in which we have a formula that utilizes the third and first quartile as far as the raw scores associated with that, and then a multiplier of 2.2 in order to determine our upper and lower boundaries for potential outliers. We then compare the actual scores to determine if any of these scores either exceed the upper boundary or are below the lower boundary.